Hey guys, today we are doing 7.7. This is solving exponential equations using logs. Let's go ahead and start with one of the warm-ups real quick. So we're looking at number one right here. We're going to try and solve this 5 to the n plus 10 equals 25. So first thing we're going to do, we want to change this 25 here in order to be a 5 base with a power. So we're going to change it. 25 is actually going to be 5 to this power of 2. So this will be 5 to the n plus 10 equals 5 squared. Now that we have the exact same base, we have this 5 and this 5 the same, what we can do is we can set n plus 10 equal to 2 and solve for it. So n plus 10 equals 2, subtract 10, n is equal to negative 8. All right, so that was our warm-up for solving an exponential equation. Now what we're going to see is what if a common base is not possible? Basically, if we can't change something like 25 into 5 squared. So first thing we're going to do, number one, we're going to try to isolate the exponential expression. Get that all by itself. Then, number two, we're going to take the log of both sides. We may need to expand the log depending on how it looks. And then, of course, we're going to solve and check for extraneous solutions. All right, so first one we have here is 2 to the x power equals 61. So let's change this into log form. So what we're going to do is we're going to change this 2 to the x equals 61. We're going to change it to log with the base 2 of 61 equals x. Because remember, the power becomes the answer for the logarithm. Now let's use our change of base form in order to solve this. So we're going to do log of 61 divided by log of 2 equals x. We're going to have to go into our calculator for this. Let's go over to our calculator application. We're going to type in log of 61, close the parentheses, divided by log of 2, and we get 5.9307. Let's go ahead and round that off a little bit. 5.931 equals x. All right, take a look at number 4 here. We have, on number 4, we have 8 raised to the power of n minus 7 is 92. Change this into a logarithm. So log with that base of 8 of 92 is n minus 7. All right, let's solve the logarithm. We're going to solve this on this side with our change of base form. So we have log of 92 divided by log of 8, still equal to n minus 7. Let's go to our calculator. Log of 92 divided by log of 8, 2.17. Let's go ahead and put that on our notes now. So we have 2.1745 is m minus 7. All right, so now we still have to solve for m. So it means that we need to get rid of this negative 7 here by adding it to both sides. So let's do plus 7 and plus 7 here. If we add that to our previous answer, this one's pretty easy. If we hit plus, changing our answer to add 7, our final answer is going to be 9.1745. All right. Okay, flip your packet over to the back side. Let's look at number 7 now. All right, here we go. We've got 7 minus 4 to the x minus 1 power equals 18. Now we can't do a change of base form yet because of this 7 here, okay? We have to move that 7 over here in order to proceed. So first thing we're going to do, get rid of it. We need to subtract 7 from both these numbers. So now we have negative 4 to the x plus 1 equals 11. Okay. Go ahead, let's multiply both of these by a negative 1. So we're going to change this to 4 to the x plus 1 is negative 11. And now we can put it into our change of base form. So we're going to do log with a base 4 taken from that 4 to the exponent of negative 11 equals the exponent x plus 1. Now here's the funny thing though, we can stop right here because of this. We said earlier, because of that, logs cannot be negative. So because of that, because we're taking a log of a negative number, we just can't even solve this at all. You could try to plug that in, it won't work. So this is no solution. And that's where we're stopping because of that negative 11. All right, going down to number 11. All right, here we have 5 times 9 to the power of v minus 1 plus 1 equals 181. All right, there's a lot of stuff we got to take care of before we can change this to a log form, okay? One thing we got to do, we're going to have to divide by this 5, but before we get to that, there's this plus 1 that we have to get rid of. So it's kind of like isolating this. We want that 9 to the v minus 1 all alone before we proceed. All right. So first thing, let's subtract 1 from this, and we're going to have 5 times 9 to the v minus 1 equals 180. Okay, get rid of that 5. So now what we're going to do is we're going to essentially get rid of this 5 by dividing both sides by 5. And if we divide, let's see, 180 divided by 5 gives us 36. Okay, so dividing by 5, we have 9 to the v minus 1 equals 36. All right, change this into a log format. So let's go ahead and do a log with a base 9. With a base 9 of 36 equals our v minus 1. All right. Let's solve this part right here. We're going to do change of base form. We're going to get an actual answer, but it will be a decimal. So we're going to do log of 36 divided by log of 9 equal to v minus 1. So let's go into our calculator and figure out what this log 36 over log 9 actually equals. So let's see, log 36, close the parenthesis, divided by log 9. And that gives us 1.6309. 1.6309. All right, I'm not going to do number 12, so I'm going to go ahead and continue this problem over here. I'm going to cross out number 12. So we got the answer of that log 36 is 1.6309 equals v minus 1. Okay. And now all we have to do is we're going to add 1 to both of those. This is an easy addition problem, so we're going to get 2.6309 equals our solution V. All right, there we go. Last one on these notes is number 14. Okay, kind of convoluted, but we can get through it. We have a few steps to take. First thing we want to do, we want to get rid of this 10 here, And then what we're going to do next is we're going to divide by 3. Okay? So first, if we subtract 10 on both sides, we're going to have 3 times 8 to the 3 minus 7n equals 94 minus 10 is 84. All right, now we're going to divide by this 3 on both sides. So if you check out your calculator, 84 divided by 3 is 28. All right, so dividing by 3, we have 8 to the 3 minus 7n equals 28. All right, now that we have 8 to a power equal to a number, we can convert this into a logarithmic form. So we have log base 8 of 28 equals the exponent 3 minus 7n. Okay. Solve for this logarithm here. So we're going to figure out what this equals using change of base form. Log 28 over log 8 is still our 3 minus 7n. Let's go to our calculator and see what that equals. So I'm going to move that up a little bit. All right, calculator, here we go. Log of 28, close those parentheses, divided by log of 8, 1.6025. All right, let's write that down. Here we go. 1.6025 is 3 minus 7n. Yeah, I'm kind of running out of room here. Let's see. Hopefully you guys have some room in your margin. All right, we want to isolate our variable n. We want to get this by itself. So the first thing that we need to do, we need to subtract 3 from both of these. I'm going to go into my calculator to see what that is. So back in my calculator, I'm going to do minus 3, negative 1.3975, okay. So we have negative 1.3975 equals negative 7n. All right, get n by itself. Let's divide this by negative 7, and let's divide our last answer by negative 7. This is why calculators are so great. Go here, hit the division button. Takes your last answer, and we're dividing it by negative 7. 0.1996. That's what our n is. The very final thing. 0.1996 equals n. All right, there it goes. I recommend going to 2 or 3 decimal places. 4 is fine as well. All right, so here are the notes for 7.7. All right, your assignment. Okay, if you're getting the homework online, the problems that I want you to do are 2 through 8 evens, and then 9 through 15 odds, which on the handout is going to be every single problem on there. There's all 8 problems printed out for you. So go ahead and try some of those. Check with me if you have any questions. Remember, get those exponents isolated before you put them into log form. All right, good luck, guys.